Hi, this is Unit 4.2 Pre-Calculus Notes. We're going to be doing stuff with the unit circle, trig values, and reciprocal functions. We're going to be graphing those as well. So what I want you to do is start off by a little warm-up here and finding these trig values from the unit circle. But I don't want you to look at the unit circle. See if you can draw this. So for instance, if I start off with this first one, sine of pi over 6. I know that pi over 6 is the 30, 60, 90. Oh, I should say 30, 60, 90, laying down. And so then the y value is this 1/2. It's the shorter side of that triangle. And since it's in the first quadrant, it's going to be 1/2. So try the rest of those, and then I'll come back to you with the answer. So if I look at this one, pi over 4, cosine would be square root of 2 over 2. I hope you get that. And then if I look at this one, my y over my x, tangent of pi over 3 is the skinny rectangle standing up. So then it's going to be square root of 3 over 2 over 1/2. Simplified, you just get square root of 3. Cosine of negative 5 pi over 6, you go down and over to here. So this is equivalent to 7 pi over 6. But then the cosine is going to be the big side of the triangle, so it's negative square root of 3 over 2. Here, this one's standing up, so then it's going to be square root of 3 over 2, and then the tangent of negative pi over 4 would be negative 1. Okay, then if we want to go ahead and do some more warm-up, I want you to graph each of the following. Negative 2 pi to 2 pi. So we start at 0, and then we go up to 0.7, and then go up to 1, and then we're back at 0. So what I usually say is that this is middle, high, middle, low, middle. And so my general shape here is going to be like this. And we flatten off. Don't make this pointy. And if I go back here, I'm going to end up with the same pattern going backwards. And so then I can get this as a nice smooth curve. It's not that easy to draw on here, but that's what works out. So what I say is that the sine starts in the middle, goes high, middle, low, middle. 5 key points. For the cosine, it's going to start high, and then it's going to go middle, and then it's going to go low, and then middle, and then high again. So this one's going to look like this. Make sure it flattens off, and then going backwards, a similar type situation. And so I get this curve here. So that's my cosine. And then the tangent, remember, is the same thing as the sine of x over the cosine of x. So I'm going to get my vertical asymptotes here. Wherever my cosine is 0, I'm going to be undefined. You cannot divide by 0. Some people still mess that up. 0 over something is 0, but when 0 is on the denominator, we get undefined. And so the sine is 0 at 0. That's how I always think of this point. And then the tangent in this quadrant is negative, and the tangent in this quadrant is positive. So at each one of these points, I'm going to be strictly increasing. That's how the tangent function looks. Okay, its period is shorter than the sine and cosine because things get replicated. And so there's the tangent. Now here's some definitions. And if we're on the unit circle, remember that r is equal to 1. So for this one, the cosine theta is equal to x, sine is equal to y, tangent is equal to y over x. That's on the unit circle. Now we have these other functions which are called the reciprocal functions. The one that matches up with the cosine is called the secant. And the secant is 1 over the cosine. It's the reciprocal. 1 over means the reciprocal. So instead of x over r, we're going to get r over x. The one that partners with the sine is going to be the cosecant. Now, these are called reciprocal functions, and how can you remember these things? What I like to think of is that each pair has a co. So the cosine and secant has one co. Sine, I don't have a co yet, so I need one, so this would be cosecant. And so how we say these things, this is secant and then cosecant. All right? So what matches up with the sine? I don't have a co, so it'll be cosecant. What matches up with the cosine? I have a co, so I don't need it over here, so it'll be secant. Similarly, the tangent has a reciprocal function too, which is called the cotangent. And that would just be x over y, which is the reciprocal there. So we say cotangent. what we want to do is try to graph those now. Now what I did back here is that I put the reciprocal function, partner function on here already. So the secant, no cos, so I need a co, is 1 over the cosine of x. So this is not the graph of the secant, but it's the graph of the cosine. And why I put this on here is because I know when I have 0 and I divide by 0, I'm going to have vertical asymptotes. And that is so easy to put here. Okay, so I get vertical asymptotes when this other graph is 0. Now, what ends up happening is that I end up, what I say, riding these waves. So if I look at this point right here, and this is the cosine. If I take 1 over 1, pretty sure that's still 1. Now, as we get out here, though, this one was about 0.7. What I'm doing is I'm taking the reciprocal of 0.7. And so when I do that, that would be a little bit more than 1. So I'm going to get a point here. Now, as I go closer and closer to this asymptote, these values are getting smaller and smaller and smaller. Well, what happens when you take the reciprocal of smaller and smaller and smaller? You're going to get bigger and bigger and bigger. So then that's what that piece is going to look like. Now, does this go down over here or what? Let's see. Well, all these values are positive. So if I take 1 over a positive, I still better get a positive. So this piece is going to look right like that. So this dark red, and maybe I should be using a different color. So this dark black, in other words, is part of the secant curve. And it's not continuous as the cosine is continuous because, well, we get these periods of undefinedness. If I take the reciprocal of -1, the y value here on the cosine is -1, so then reciprocal, that's still -1. And same kind of thing here is that as I get closer to 0, if I take the reciprocal of a very, very small number, I'm going to get a very big number. In this case, all of these values are negative, so I'm going to be going down towards these asymptotes. What I like to say is that the reciprocal functions just ride the wave of their partner function. So then this one will go to here, and then once again we'll have this and this. Okay? So the cosecant is equal to 1 over the sine. I'm going to let you graph that. See if you can do the same thing that we did over here, a similar thing, and go ahead and graph that. So there we go. We just ride the waves. So this reciprocal function rides the waves. I should have maybe flattened this out a little bit more, but that's the general shape. You can go ahead and graph these on your calculator. And here's the graph of the secant function. On the Inspire, I can just type in secant. If you have an older calculator, you might have to just put in 1 divided by the cosine of x. And notice I did have to put the secant in parentheses. I believe that that's true for this calculator. And it does not show the vertical asymptotes, but you can figure out where those are because that's based on where the cosine function is. And then there's my cosine function. That's how it turned out. Nice. All right, moving on. Now I want to graph the cotangent function, and I can look at this as being the reciprocal of the tangent, or I can work it off of the sine graph. Either way, it should turn out to be pretty much the same. This one would be the cosine over the sine. It's a reciprocal of the tangent, so that's what we end up with. So regardless, if you look at the tangent and the sine function, both of them occur at 0 simultaneously, or every time one's a 0, the other one's a 0. So regardless with this, I'm going to end up with vertical asymptotes wherever the tangent's 0 or the sine is 0, because I'm taking the reciprocal of the tangent function. Now, what is this going to look like? Well, this one's going to be a little bit different. Now, if I take the reciprocal of all these numbers, this is the tangent. These are all positive numbers. And as I get closer and closer to 0 here, the reciprocal is smaller and smaller, and I need to approach my vertical asymptote, top or bottom. Well, these are all positive, so this is going to go off to positive infinity. And then also, and if I look over here, these are negative values, so similarly, I'm going to have this, but going off to negative infinity. Now, what happens in between? Well, since I'm cosine over sine, the cosine at pi over 2 is 0. So 0 divided by 1, yeah, the sine function's 1. 0 divided by 1 is going to give me 0. So when I graph this, this is going to look like this. How's it going to look over here? Well, it's going to be exactly the same. If I take the reciprocal of this, I have the vertical asymptote behavior there, and I'm going to end up with a 0 in there because the cosine is 0 at 3 pi over 2. Then I'm going to come down and look like that. And I think you can figure out this pattern now. So this is what the cotangent is. Now some of the differences between the tangent and the cotangent function is strictly decreasing. And then the tangent function is strictly increasing. Okay? And then also the tangent function goes through 0, 0. The cotangent function has a vertical asymptote there. So these vertical asymptotes are at a different marker than for the tangent function. They're based on pi's. Okay, then why don't we find some of these inverse functions or values and see how we can do this. Okay, so this is the cosecant, so I know that I'm looking for the sine. The sine of pi over 6 is going to be 1/2. So I'm going to have the reciprocal of 1/2, which turns out to be 2. Oh, so the sine is between -1 and 1, but the cosecant is going to be above 1 or below -1. Oh, range issues. Okay, good. Here I don't have a cos, so I'm looking at the cosine. The cosine of pi over 4 we found to be square root of 2 over 2. Well, the square root of 2 over 2 comes from the fact that that's the square root of 1/2. So if I take the reciprocal of that, that is just going to be the square root of 2. Figure that out if you can. If that doesn't make sense, try to sort it out. Here's the cotangent. It's going to be the reciprocal of the tangent. Otherwise, you could say that the cotangent of any angle is going to be equal to, now we put the cosine on top, over the sine. So at pi over 3, the cosine is going to be 1/2, and the sine would be square root of 3 over 2. So if I do this, 1/2 and then square root of 3 over 2, that turns into a 1 over square root of 3 situation. We rationalize, we're going to get square root of 3 over 3. Okay? Secant. Remember that this goes along with the cosine. So the cosine over here at 5 pi over 6, what is the cosine? It's negative square root of 3 over 2. So when I flip this over, I get 2 over the square root of 3. But I'm going to rationalize that by multiplying top and bottom by the square root of 3. And the reciprocal of square root of 3 over 2 turns out to be 2 square root of 3 over 3. Rationalizing isn't my favorite thing, but you got to do it to recognize these other ones. Okay, cosecant means that I work off of the sine. And so the sine of negative 4 pi over 3 brings me up here. The sine is square root of 3 over 2. Ooh, I got to do the reciprocal of that again. And it's going to be positive, so it's going to be 2 square root of 3 over 3. And now the cotangent of negative pi over 4. Down here, cotangent, well, it's similar to the tangent, but I put the x over the y. Well, regardless, they're the same value, but one's negative. So this would be -1 here. Okay? So hopefully you're getting that. Now let's try some of these last ones. You've done some of these, so why don't you go ahead and try these and see if you can find these values. I'll try to talk about these once I get there, though. Okay, now check these first 3 that we've done. And I talked about the bow tie in class, but this is the bottom part of the bow tie because the sine value, the y value, is negative. So it's the bottom parts. And so we get 7 pi over 6 and 11 pi over 6. This cosine, you get the left part of the bow tie because the x value is negative, so that would be 2 pi over 3 and 4 pi over 3. Tangent being -1, well, those go straight across. The tangent's negative in the second quadrant, fourth quadrant, so we get 3 pi over 4, 7 pi over 4. Now how about this one? Well, this one you can do a few ways, but if you notice this piece right here, that's the same thing as saying that the cosine of theta is equal to square root of 3 over 2. So if that's the case, then that makes this a little bit easier. Cosine being square root of 3 over 2 would be this piece right here, and then so I'd have these 2 triangles here. It'd be the right parts of the bow tie, and so that would be theta is equal to pi over 6 and then 11 pi over 6. So this little piece, and then all the way around to this other piece. And then the cosecant of theta equaling the square root of 2. Well, if I take the reciprocal of this, means the sine of theta is equal to 1 over the square root of 2 is a square root of 2 over 2. So when is the sine of theta that? Well, it's going to be the top parts of my bow tie. And so those two pieces there tell me that theta would be equal to pi over 4 and then also 3 pi over 4. So hopefully you were able to try those and see where they're at. Now this last piece is different from this one, simply that it says find all values of theta. This up here just said between 0 and 2 pi. So if it says all values of theta, that means I got to include all the whip arounds that we have. So what happens is that we have our same basis, 7 pi over 6 and 11 pi over 6. That's what we got from up here. What we do then is we say, okay, I can whip around the circle another time, and another time, and another time. Get all the coterminal angles possible that also line up with this 7 pi over 6. Well, we don't write all of them. So what we do is we say 2k pi, or 2n pi. And this one would be also 2k pi. What that means then is that if I go to 7 pi over 6, which is right here, how do I get to the next one? Well, that means I can jump around another 2 pi. Oh, k is 1. K's are integers. I can jump around another 2 pi. That's another one. Jump around another one. In fact, I can go backwards, because k could be negative. So this would incorporate all of the angles that would end up here at 7 pi over 6 coterminally. And then we also do the same thing for 11 pi over 6. Why don't you finish up these other ones? I think hopefully they make sense after that, and we'll see what you got. So all I did was I took 2k pi and applied it to each one of these values from up here. Now let me show you something here though. What happens with the tangent's funny because you can compartmentalize this answer a little bit better. Tangent will always go what I call the airplane propeller. It goes straight across. These, it doesn't do that. It goes opposite sides. Well, if it goes straight across for the tangent, that means that each one of these sides will differ by a value of pi. So 3 pi over 4 differs from 7 pi over 4 by pi. So how to compartmentalize this thing is that we simplify it by saying that theta is equal to, I don't know what, everything blanked out. Theta is equal to 3 pi over 4, and I can go plus k pi. This is a simplified version because this also includes 7 pi over 4 because from 3 pi over 4 to 7 pi over 4, I just go pi units. Notice it's not 2k pi anymore. It's just pi, k pi. All right, so that's a simplified form. So hopefully this gives you a little bit more background. I think in class you're going to do a worksheet and then also some web assigns, so be prepared for that. Thank you very much and have a great day.